And then there is another level where you go deeply into it, and Patanjali and all the other mystics and people that went beyond what they saw, they called it energy, or they called it chi, or they called it the life force behind everything that we see around us. And so bridging the gap between what the ancients knew already, when I say ancient, it doesn't mean 10,000 BC. We're just talking about a couple of hundred years ago, before science became the dominant religion and the dominant way of thinking. When I talk about science, I'm talking about modern day science, because exploring the mind, exploring the body, exploring the energy is also a form of science, except science has become very focused on matter. And so then we developed all these different microscopes and ways of looking further into the organisms and things like that, which, as scientists began exploring more and more, the deeper they observed, the more they saw. So when they're trying to isolate something, they realize that there's more levels of looking even deeper into it. So in quick summary, you have, we could say, in our human body, we have organs, we have molecules, we have cells, and then inside those cells, you could say we have atoms, and then within those atoms we have what? What happens? Most of the conventional science, unless you study this, is it stops at atoms. We're composed of atoms, but what's inside the atom? Now with these new colliders and extremely sophisticated equipment, we can go inside the atom, which then reveals this something else that you can go inside that. But most of us stop at the atom, but then they found a neutrino, they found a quark, and they found these other things. And I'm going to share a little screen with you here. If anybody's bored with this, I'll talk about something else as well. So you let me know. And I won't talk too much about it. I don't want to lose anybody into a very technical scientific jargon here. So let me just see. Where does it share the screen? Any questions so far, by the way? Why did I look for these buttons? Something I forgot to do is look for a button. Any thoughts, any questions? Does everyone understand what I am saying already? I'm just building up the story to something. Where is it? Present now. Okay, here we go. A tab. Okay, so you should all be able to see this, right? I'm assuming. Okay. So where was it? So here we have this scale. Can someone just give me a voice that they can see this? Because I can't see anybody's faces. Okay. No, I can't. Are you looking at it on your phone? Okay. Going to be a bit of a struggle on the phone. Okay. Well, you don't have to read the writing or anything like that, but I just wanted to show you the scale. So if you can see that there's actually a chart that looks like a thermometer. This top part is showing a person, then it's showing a blood cell, then it's showing an atom. And this is where we really, most of our, if we did physics in school, sort of stop here. Then we have the atomic nucleus. And as we move down, we have, so this is a meter, millimeter, micrometer, nanometer. Then we get down here to words that you never heard of, a femtometer, atometer, and then you have zeptometer, and then they just can't think of, they're going to come up with all these funny names like we have with delta and beta and cuta, and until we exhaust every name for a virus that we talk about. So as you go further down, there's this thing called Planck in the French, if you say it in the French way, or Planck. And Planck was named after a physicist called Max Planck. Now, at this scale, that is 10 to the minus 35 or close to 10 to the minus 40. That means if you had to say zeros wise, if I started on the left and I put zeros, it would be that many zeros going across and then that many zeros going across. So let me stop sharing that screen and come back to me. All right. So as you can tell, just based on that, that's a lot of zeros, and we're zooming in very far because we have the technology now. Now, let me ask you a question. If we zoomed into the Planck scale at that, I mean, I'm doing that, but it's not like that. Do you think we'll find something else? So Einstein believed that we as humans were separate from the universe. So Einstein did contribute a lot, so not taking away from him, but then he said, We are here, and then the universe is happening. In other words, if you weren't here, the universe would still be here. So another quantum physicist at the time named John Wheeler made some interesting discoveries at the time, and he made the statement. And he says, for the summary is, we live in a participatory universe. We live in a participatory universe. And then he explains, when you look for something, you will find it. Why is that? Because your looking creates it. You see that? It's a total mind bender. So, my wife was watching one of these hospital shows, and the guy walked in, and a top-notch executive in perfect health. And the doctors, he said, look, I want a full tune-up. Every single scan you can think of, X-rays, CT scans, bone scans, blood tests, do the works. And they did. And they said, you're in perfect health. But there's one thing that we did see, that there's a malignant tumor in one part of your back, but it's not causing any trouble. And really, if you didn't look that closely, you wouldn't even notice that it's there. And he says, listen, I came here to get top shape, and I want to be in top shape, which is this big trap. So they said, all right, we can remove the tumor, although it's not causing any problems, and it's pretty much, it's not going to cause you any issues. But there's a chance that you could have some repercussions with it. He said, listen, I don't care. I want to be in top shape. Anyway, they did it. He became paralyzed because that particular part of the tumor was sitting on a nerve ending connected to his legs. His legs didn't work anymore. And then they said, would you like to dig any further and find if there's anything else? It's quite a sarcastic statement, right? And he said, what's the point? I can't walk anymore. Now, here's the question. If he didn't look that deeply, would it affected him in any other way? No, because he was in perfect shape. So now, was the act of looking, waiting to find something, causing that thing to appear? This is mind-blowing, because this is where the quantum world moves away from the conventional thinking. And I'll show you proof of this. You walk in the street, right, hoping that you don't trip on something. Do you know that your chances of tripping have now become 5 times more than when you weren't aware of avoiding tripping? Why is that? Right? Which is mind-blowing. Now, you look at this particular thing, and I asked you the question, if we go to the Planck scale and we look further, will we see something? Yes, we will. And what gives us guarantee? Because of John Wheeler's statement is that we live in a participatory universe. Understand this. If you go looking for something, you will create it. Now, just the same way that he created that tumor, you can also create another reality where you say, I want to create supreme health. And I'm going to go look for supreme health in myself. And guess what you find when you're looking for it? You find supreme health. And when you're looking how successful you are and you go and look for confirmation, you live in a participatory universe. And I'm sure you guys know about the double split experiment where they took, I'm not going to go into that experiment, but you can look it up if you'd like to. And these other experiments with co-location, I mean, quantum physics just blew me away. I won't go too deep in the topic because I can talk for hours and hours, and it does get fascinating. Because it's so early in the morning in the US, you're like, I need more coffee for this conversation. Now, what's interesting, when they observed at Planck's scale, time. So in other words, if at Planck's scale they said, okay, start the timer now at 1 minute, 1 second, and stop the timer at 1 minute, 3 seconds, how much time has elapsed at Planck's scale? There was no ability to differentiate or to measure time because time does not exist at Planck's scale. Now, if you can understand that implications, that if Planck's scale is the most smallest, finest downward estimation and breakdown of all of this, that's me. There's billions and trillions of Planck inside of me. And then you go whoosh, all the way up, and then you're getting to atoms, and then you